Hello everyone, this is Abhishek KB. Welcome to my YouTube channel. I hope you are all studying well. Yes, last class we completed the derivative of composite function using chain rule, then the derivative of implicit function, then the derivative of inverse trigonometric functions, right? So today I am going to give a lecturing about the derivative of logarithmic and exponential function. Before going to know about the derivative of logarithmic and exponential function, first I would like to recall the definition of logarithmic function and exponential function. We already learned in our school level only, right? So, if I consider the definition of exponential function, consider any real number, say a, such that that number should be greater than 1. Then the function of the form a to the power of x. The function of the form a to the power of x is called exponential function. And if I consider the domain and range, domain is nothing but set of all input, range is nothing but set of all output. Set of all inputs for the exponential function is set of real number, range is that is output, that is set of all positive real number. For any real number we will getting the positive real number only. That is for any input, that is for real number we getting the output as positive real number only. So its domain is set of all real number, range is set of all positive real number. And here the function of the form 10 to the power of x is called common exponential function, and the function of the form e to the power of x is called the natural exponential function. Here e is a number between 2 and 3. E is a number between 2 and 3, and the graph of the exponential function is given by, see, if I consider this y function as y is equal to 10 to the power of x, then graph will be like this. See, for example, if I have y is equal to x, see, y is equal to x, y is equal to x. See, the graph is like this. If I consider y is equal to x square, then it is what? Parabola. Since the output is positive real number, we don't have the negative part. Therefore, we don't have the negative part. Therefore, we have what? This is for what? Y is equal to x square. Y is equal to x square. See, this is 0, 1. This is 1, 1, right? Similarly, for y is equal to x cube, we get it like this. See, y is equal to x, y is equal to x square, y is equal to x cube. Similarly, for x to the power of 4, x to the power of 5, like this. What happens here? Observe, the power of x increases, the graph is more steeper and steeper. Is it clear? So this is the graph for exponential function, and this is about the definition of exponential function. We already learned in our school level only, right? So let us move on to the definition of logarithmic function. See, let a be a real number such that a should be greater than 1. If a to the power of b is equal to x, if a to the power of b is equal to x, see, this is what? Exponential. A to the power of b, a is greater than 1. See, we already recall, for a greater than 1, a to the power of x is called exponential function. For a greater than 1, a to the power of b is called also exponential function. If the a to the power of b is equal to x, we denote log of x to the base a. See, we say log of x to the base a is equal to b. We say log of x to the base a is equal to b. Log of x to the base base 10 is called the common logarithmic function. Log of x to the base e is called the natural logarithm of x. Is it clear? Log of x to the base 10 is called common logarithm of x. Log of x to the base e is called natural logarithm of x. See, here the domain is set of all positive real number, the range is set of all real number. But here the domain is set of all real number, range is set of all positive real number. For exponential. For logarithmic, domain only the set of a positive real number and the range is set of a real number. Okay, see, this is the graph. When I consider log of x to the base 10, the graph will be like this. See, if I consider log of x to the base e, log of x to the base e, then the graph is this one. Similarly, log of x to the base 2. See, the base decreases. When the base increases, the graph is steeper. Base increases, the graph is steeper. And here we should remember both exponential and logarithmic functions are increasing functions. Is it clear? Both we will discuss what is increasing and decreasing function in the next chapter, that is application of derivatives. We should remember both logarithmic and exponential functions are increasing function. So this is about the definition of logarithmic exponential function and logarithmic function. Let us recall the properties of logarithmic function. See, log of xy, log of xy is equal to log of x plus log of y. Then log of x by y is given by log of x minus log of y. Log of x to the power of n is equal to n into log of x. N into log of x, and log of x to the base x. When the exponent and the base are same, this is equal to what? 1. And what is log 1? It should be equal to what? 0. Whenever you getting this result log 1, then you should put that result is equal to 0, because log 1 is equal to 0. You should remember these properties. These are all very important when we are going to solve the problems on the derivative of logarithmic function. Is it clear? So you should remember the definition, graph of logarithmic and exponential function, and the properties of logarithmic function. Is it clear? Please note. Yes, let us move on to the problems on the derivative of exponential function. Before going to solve the problems on the derivative of exponential function, first we should know what is the derivative of exponential function, right? See, so this is the main note, okay? Derivative of exponential function, that is e to the power of x with respect to x, is that function only. Please note. See, derivative of exponential function with respect to x is exponential function only. See, e to the power of x, that is derivative of e to the power of x. Derivative of e to the power of x with respect to x is e to the power of x only. See, example like this type of question. Differentiate the following with respect to x. Differentiate the following with respect to x. First one is e to the power of minus x. So let us consider let y is equal to e to the power of minus x. Let y is equal to e to the power of minus x. Differentiate both sides. Differentiate both sides with respect to x. With respect to x. See, then d by dx of y is equal to d by dx of e to the power of minus x. E to the power of minus x. See, derivative of y with respect to x. Derivative of one parameter with respect to another parameter, it remains same. That is d by dx. They are already learned in previous sessions, right? So this is equal to, see, derivative of exponential function with respect to x is exponential function. But here the derivative of it is an exponential function with the negative power, right? E to the power of minus x. See, derivative of exponential function is exponential function. Derivative of exponential function is exponential function. Here the exponential function is what? E to the power of minus x. There positive, here negative. Yes, derivative of e to the power of minus x is e to the power of minus x. But we need to derive this minus x. Is that it? See, derivative of e to the power of x is e to the power of x into derivative of e to the power of x. We cutting this child exponential. Still we are remaining with this side. We are all know derivative of x with respect to x is 1. So I already told you, no need to write this. If the derivative of one parameter with respect to the same parameter is 1, so no need to write this. But here we have the derivative of minus x. Minus x is different from plus x. So, see, this is equal to e to the power of minus x. Derivative of minus x is minus 1, right? Derivative of x with respect to x is plus 1. Derivative of minus x with respect to x is minus 1. Taking this minus outside, then plus into minus. This is equal to minus e to the power of minus x. That is derivative of what is y? Y is equal to e to the power of minus x. Minus x is minus e to the power of minus x. I hope you are all getting this. Please note down. Yes, let us move on to the next type of problem. See, the second one is y is equal to cos inverse of e to the power of x. We need to find the derivative for this function. So, differentiate both sides. Differentiate both sides with respect to x. Then we get dy by dx is equal to d by dx of cos inverse of exponential function. Right? So, derivative of cos inverse, see, it is of the form of cos inverse of x. But instead of x, what we have? Exponential. That is e to the power of x. Same. See, what is derivative of cos inverse x? We already learned the derivative of inverse trigonometric function in the last class, right? So, derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. So, this is equal to what? Minus 1 divided by square root of 1 minus instead of x, what we have? Exponential function. So, we need to write the exponential function. From this, we cutting this type cos inverse, but still we need to derive this exponential function. Is it clear? If it contains x, so this is the only solution. Instead of x, what we have? Exponential. So we need to apply the chain rule. First we cut this chain cos inverse, then we need to find the derivative of exponential. This is equal to minus 1 divided by square root of 1 minus e to the power of x square. E to the power of x whole square is given by what? E to the power of x square into derivative of e to the power of x is what? E to the power of x. Because the derivative of e to the power of x is e to the power of x. So this is the answer. d by dx of what is y? Y is cos inverse of e to the power of x is cos inverse of e to the power of x is minus 1 divided by square root of 1 minus e to the power of x square into e to the power of x. Please note down. So let us consider the next problem. Y is equal to e to the power of cos x. Again, differentiate both sides with respect to x. Then dy by dx is equal to e to the power of cos x. Sorry, d by dx of e to the power of cos x. See, it is of the form what? E to the power of x. Derivative of e to the power of x is e to the power of x. What is derivative of e to the power of cos x? It is e to the power of cos x only. E to the power of cos x, but we need to differentiate. See, here we are cutting this an exponential only. Instead of x, what we have? Cos x. So we need to derive the cos x with respect to x. Here we have x, so no need to write. D by dx of x is 1. But here, derivative of e to the power of cos x, e to the power of cos x into derivative of cos x. We need to differentiate this exponential. What is the exponential here? Cos x. So we need to differentiate cos x. See, you know e to the power of cos x, derivative of cos x is minus sin x. So we are getting minus e to the power of x into sin x. Therefore, d by dx of plus y is equal to e to the power of x, right? So this is the solution. So these are all some examples for derivative of exponential function. I hope you are all getting this. Please note down. Yes, let us move on to the problems on the logarithmic function. That is the derivative of logarithmic function. Here also we should note the derivative of logarithmic function with respect to x is 1 by x. Is it clear? See, derivative of e to the power of x with respect to x is e to the power of x. This is for exponential function. Then derivative of logarithmic function is 1 by x. And here x should not be equal to 0. Is it clear? Yes. So let us move on to the problems. Before going to move on to the problems on the derivative of logarithmic function, I already told you about the properties of logarithmic function, right? So you should remember that. See, log of xy can be written as log x plus log y. Logarithmic of product of two variables is sum of the logarithmic of those two variables. Then logarithmic of quotient x by y is log x minus log y. Then log x to the base x. Both exponent and base are same. Then its resultant is 1. Log 1 is equal to 0. Log x to the power of n can be written as n into log x. And one more, a to the power of log x to the base a. See, the main base is a. Base of logarithmic is a. When these two are same, that is main base and logarithmic base are same, this resultant equal to x. That is a and log a can cancel. We are remaining with x. So these are this is enough to solve the problems on the derivative of logarithmic function. So you should note down and please add these two formulas to your standard derivative list. That is derivative of e to the power of x is e to the power of x. Derivative of log x is 1 by x. Yes, for your annual examination, examiner like to ask this type of question. Differentiate the following. Differentiate the following with respect to x. Differentiate the following with respect to x. First one, y is equal to square root of x minus 3 x square plus 4 divided by 3x square plus 4x plus 5. Well, see, when the function of the form y is equal to xy or y is equal to x by y or y is equal to x to the power of n or y is equal to any trigonometric function, we are all know how to derive these standard forms. See, derivative of product function is derivative of first into second. We use that formula. First into derivative of second plus second into derivative of first. Then the derivative of quotient function is numerator by denominator. Derivative of x to the power of n is n into x to the power of n minus 1. And derivative of trigonometric function, sin x is cos x. Similarly, cos x is minus sin x. And also inverse trigonometric function. We have already learned that the derivative for all these standard form. But here, see, it is of the form quotient. Even though it has the form quotient, but see, root of this can be written as whole thing to the power of 1 by 2. Then it is of the form what? X to the power of n. X to the power of n, then numerator has the function of 2. Denominator 3x is a polynomial function. So it is not possible to apply any of these standard form. That is the derivative of x to the power of n. It's not possible. 1 by 2 this, then again quotient. It's little bit difficult, right? So let us say for this kind of problem, let us take log on both sides. Take log on both sides. Then we will get log y is equal to logarithmic of x minus 3 x square plus 4 whole thing divided by x square plus 4x plus 5 whole thing to the power of 1 by 4. See, it is of the form log Here 1 by 2 log of x minus 3 into x square plus 4 divided by x square plus 4x plus 5. See 1 by 2, see log of, it is of the form what? X by n. Log of x to the power of n reduces to n into log of x by n, x by y. See log of x by y can be written as log x minus log y. Instead of x we have x minus 3 into x square plus 4. Instead of y we have x square plus 4x plus 5. Therefore 1 by 2 into log of x minus 3 into x square plus 4 minus log of 3x x square plus 4x plus 5. And here 3x square, right? 3x square plus 4x plus 5 with the multiplication of 1 by 2. This is equal to 1 by 2. See, log of AB. Again it reduces to log of AB. We know log AB is equal to log A plus log B. Therefore, log A plus log B minus, see, it is the whole polynomial function. So, let us write the same polynomial function 3x square plus 4x plus 5. So, this function, see, this function reduces to this function. See, x to the power of n. If I take log on both sides, then n into x to the power of n. Then it reduces to a by b. Log of a by b, log a minus log b. Again, we have the product. It is of the form log a, log a plus log b minus this. See, this is equal to what? Log a. This is equal to what? Log a. Now differentiate both sides. Differentiate both sides with respect to x. See, then d by dx of log y is equal to 1 by 2 is constant, take outside. D by dx of, see, d by dx of u plus v plus z. See, if I consider these three function as u, v, z or x, y, z, x, y, z, log of, derivative of x plus y plus z is derivative of x plus derivative of y plus derivative of z. So, similarly, you can write derivative of log of x minus 3 plus derivative of log of x square plus 4 plus derivative of log of 3x square plus 4x plus 5. 4x plus 5, close the bracket. This is equal to, see, derivative of log y with respect to x. Parameter are different. Derivative of log x is 1 by x. Instead of x we have y. But we should differentiate again with respect to x. Then we will get dy by dx by chain rule. First we cut this chain, then for this dy by dx. I hope you are all getting this. Yes, 1 by 2 into d by dx of log of x minus 3. See, it is 1 by x minus 3. Derivative of log x is 1 by x. Instead of x we have x minus 3. So log of x minus 3 is 1 by x minus 3. 1 by x minus 3 into derivative of x minus 3. Derivative of x minus 3 is, see, it is of the form u minus 2. Derivative of u minus derivative of v. Derivative of x with respect to x is 1 minus derivative of the constant function 0. So we are remaining with into 1 plus derivative of log of x square plus 4. 1 by x square plus 4, then the derivative of x square plus derivative of 4. Derivative of, what is derivative of x square? 2x. It is of the form x to the power of n. For n is equal to 2, 2 into x to the power of 2 minus 1. This is equal to 2x. Derivative of 4, 0, because it is a constant function. So 2x into 1 by x square plus 4 plus derivative of log of this, again 1 by 3x square plus 4x plus 5 into the derivative of 3x square plus derivative of 4x plus derivative of 5 by chain rule. Derivative of 3x square is 6x, that is 3 into x square. Derivative of x square is 2x, 3 into 2x, 6 into x, 6x plus derivative of 4 into 4x is 4. 4 into 1, derivative of x is 1. That's why we can write derivative of 4x as 4 plus 0. So no need to write it. Close the bracket. So 1 d by dx of what is y? The given y as x minus 3 x square plus 4 divided by 3x square plus 4x plus 5. This is what square root of this is equal to 1 by y transferred to RHS. See, this denominator becomes numerator, y by 2 into 1 by x minus 3 plus 2x divided by x square plus 4 plus 6x plus 4 divided by 3x square plus 4x plus 5. We should replace this y. What is y in the given question? So we need to find what derivative of this function. So this is not the final answer. This is the final answer. From this also we should replace this y. What is y? Square root of this. Given question. Y is equal to square root of x minus 3 x square plus 4 divided by 3x square plus 4x plus 5 divided by 2 into this. So this is the way to find the derivative of the logarithmic function. We need to apply log on both sides. By using these properties, we manipulate the given equation. Then after getting the suitable equation, then we are going to differentiate on both sides. Again, we will do this. I hope you are getting this. Please note down. Yes, let us move on to the next type of problems on the derivative of logarithmic function. Also the exponential function. Yes. See, differentiate x to the power of sin x for x greater than 0 with respect to x. See, let y is equal to x to the power of sin x. See, it is not of the form x to the power of n. Here n is what? N is a constant greater than 0. But here n is a what? Function. So we should not consider this function is of the form x to the power of n. So we should take log on both sides. Then log y is equal to log of x to the power of sin x. X to the power of sin x. Then this becomes what? Sin x into log x. By the property log x to the power of n can be written as n into log x. Then here it is of the form x to the power of n. This can be written as sin x into log x. This is equal to log. Now we can easily apply the derivative. That is differentiate both sides with respect to x. Then 1 by y, that is what? D by dx of log y is equal to d by dx of sin x into log x. See, d by dx of log y is 1 by y into what? dy by dx, because this parameter with respect to another parameter. So we need to differentiate y with respect to x after differentiating log y. This is equal to d by dx of sin x into log x. See, this is the first function, this is the second function. Using the derivative of first into second. First into, that is sin x into derivative of log x. Derivative of log x. Plus second into, what is the second function? Log x into derivative of first function. What is the first function? It is sin x. Therefore, sin x into derivative of log x is 1 by x. Since both parameters are same, so no need to differentiate again. Log x into differentiate of sin x is cos x. That's all. Therefore, d by dx of what is y? X to the power of sin x is equal to, see, 1 by y is here into, you should replace this y. What is y? X to the power of sin x. See, this is the answer. Okay? Then consider the second problem. Differentiate a to the power of x with respect to x, where a is a positive constant. See, let y is equal to a to the power of x, a is greater than 0. Here also taking log on both sides, then log y is equal to log a to the power of x. Log a to the power of x can be written as x into log a. Therefore, log y is equal to this. Differentiate on both sides. Then d by dx of log y is equal to d by dx of x into log a. See, yes, it is a two function. First function is a x. Second function is constant function. This is polynomial, but this is constant function. So no need to take this as a second function because derivative of constant function is 0. So take this as outside. That is log a into d by dx of x. Therefore, d by dx of log y is 1 by y into d by dx. This is equal to log a. D by dx of x is 1. Therefore, d by dx of what is y? A to the power of x is equal to 1 by y is transferred to this side. That is y into log a. What is y? Y is a to the power of x. So we should add this derivative of a to the power of x. See, this is not of the form x to the power of n. Don't confuse that. Derivative of x to the power of n is n into x to the power of n minus 1. Derivative of a to the power of x is a to the power of x into log a. Please add this formula to your formula list. Yes, let us move on to the next problem. Third problem, let y is equal to cos x into cos 2x into cos 3x. See, here we have three functions. Cos x is the one function, cos 2x is the another function, cos 3x is the another function. Totally we have three functions. We know the derivative for two function is first into derivative of second plus second into derivative of first. But we don't know about the derivative of three function. So let us take log on both sides. See, log 1 is equal to log of cos x into cos 2x into cos 3x. See, it is of the form log a b c. Log a b is log a plus log b. Similarly for three function, log a b c is log a, that is cos x, plus log b, that is cos 2x plus log 3x. See, then it is what? Log a. Therefore, taking derivative on both sides, that is differentiate both sides with respect to x, we get what? 1 by y into dy by dx. This is equal to, for log of cos x is, that is, take derivative on both sides, d by dx, d by dx, d by dx, right? d by dx. Derivative of log x is 1 by x. Instead of x, what we have? Cos x. We should differentiate again cos x with respect to x. That is minus sin x plus derivative of log of cos 2x is 1 by cos 2x. For cos 2x minus sin 2x. Again for 2x log cos 2x. Totally we have 3 by chain rule. Log is 1 by x. Again for cos 2x minus sin 2x into 2x. 2 into for x is 1 plus dx, d by dx of log of cos 3x. Log of cos 3x. For cos 3x 1 by cos 3x. For cos 3x minus sin 3x into 3. Therefore, see, we should transfer this denominator to RHS, then it becomes numerator. d by dx of the given function cos x, cos 2x, cos 3x. Cos x, cos 2x, cos 3x. This is equal to y. What is y? This one also. That is cos x, cos 2x, cos 3x into minus sin x by cos x, tan x. Tan x plus into minus sin 2x by cos 2x, 2 into tan 2x. Similarly, plus into minus sin 3x by cos 3x, 3 into tan 2x. See, this is the solution. For this time, x to the power of sin x also we should take log on both sides by using the properties. For this also, 2 or more function. So 3 or more function cos x, we should take the log on both sides again by using the property. This I already gave that properties, right? So those are very important basic tool to solve the problems on logarithmic and exponential. So this is about the derivative of exponential function and logarithmic function. From this part, you will definitely getting 3 marks for your annual examination in part C. I hope you are all getting the idea of derivative of exponential function, derivative of logarithmic function. Please go through my notes which is available in description part of my YouTube channel. Yes, thank you everyone. I will meet you in the next session with the derivative of parametric function and the second derivative. See. bye.